And you've probably heard a lot of your friends talking about which snowpack test is best when and which one's their favorite. But we haven't talked very much about comparing the actual snowpack tests with observations. We're actually using these snowpack tests and observations for localizing the avalanche danger, and it will help us understand which is best when we think about avalanche problems, which is now used in avalanche and another avalanche forecasting situations here. It's also called avalanche situations in Switzerland. I'll review some research results from snowpack tests and also some quick observations. So this study was conducted on the south coast up here through the Columbias and in the South Rockies. In the next slide, I'm going to go our image of the South Columbias. Here we see the 20,000 square kilometers of the South Columbias, and the regional avalanche forecasters put a danger rating of below tree line, 1 at tree line, and 1 for the alpine. Now this yellow square is 10 square kilometers, and that's about the area we're exposed to in a day of ski touring or snow viewing or backcountry snowboarding. And so there's a huge difference in scale between the public avalanche bulletin and the area that we're really interested in, which is the local danger here. And so it's actually observations and perhaps snowpack tests that help us localize the avalanche danger in the area that we're in. How did we do the study? Well, this is Napoleon Spur at Rogers Pass, and we did a ski tour up, working our way from the highway through the openings in the trees. This is just typical, doing observations as we went. When we got into these openings up near tree line, we did more observations and more snowpack tests, right? And these openings were considered good places to do our observations, and these wind-affected avalanche terrain up here was considered poor places to do observations, and we did not use them in this particular study. This is the Swiss brochure for the public on avalanche awareness, and you'll notice they divided up into 4 different avalanche problems: new snow, wind loading or wind slabs, wet snow, and old snow, what we would call persistent slabs over through here. I know this is hard to read, but I'm going to zoom in here on the bottom right. Here we see simple snowpack tests are often useful. This is the only one of the 4 avalanche problems for which snowpack tests are recommended in the Swiss brochure to the public. And they also note that these old snow problems or persistent slabs are difficult to recognize. So summarizing our research results for the snowpack test into one slide here. For the rich block, we see a correlation with the local avalanche danger of minus 0.33. It's negative because the higher the rich block score, the lower the avalanche danger. But notice the magnitude, not that high, 0.33. For compression tests, again, it's negative, and the magnitude is 0.30 for compression tests. So remember these numbers, 0.30 and 0.33. For our quick field observations, most of them were done as in this picture here, just looking around, being observed. Recent avalanches, wind-blown snow, the ski tracks, how much fresh snow was falling overnight in the last 24, 48 hours. For these quick observations, and these are some of the ones that correlated best, here we see some of the correlations. When non-persistent avalanche problems were dominating the bulletin, that is, wind slabs and storm snow, we see correlations like this here, ranging 0.34 to 0.68. And when persistent avalanche problems are dominating the bulletin, we see correlations ranging from 0.27 to 0.49. And this includes persistent slabs and also the really deep persistent slabs that are so very hard to forecast. What we see here is that we have more correlations here for the non-persistent avalanche problems than we do for persistent, and the correlations are generally higher. So we have better indicators of non-persistent avalanche problems such as storm scale avalanches, wind slabs, than we do for persistent and deep persistent. I think if we had more data over here and have a summary column for the really deep persistent avalanches, we'd see even lower correlations as well because they're really hard to forecast. If we look at various indications of recent snowfall, such as the snowfall rate at the time of the observation, the snow height in the last 24 or 48 hours, or ski penetration, we see some of our best correlations here, and they are particularly good for the non-persistent, that is, the storm scale avalanches and the wind slabs. So, summing up, we see that field observations are important for localizing the avalanche danger. We get some reasonable correlations for there, and there's certainly better correlations for our quick field observations than we are for the snowpack tests. And the correlations are better for the non-persistent avalanche problems and than they are for the persistent avalanche problems. And for the persistent slabs, point and switch is that the snowpack tests can supplement the observations. Lots of people helped with field observations for this study. These are the organizations that helped with the logistical support. These are the organizations that helped us pay the bills and financially support this study. Thank you.